Hello YouTube, welcome to part 2 of my DIY mini wind turbine build. I've got one loose end I wanted to tie up from the previous video. We talked about the rotation stop of the wind turbine. In this case it was a bolt in the tail versus a bolt in the water pipe. Now this wind map came from the college where I live, and it shows that our predominant wind is from the south and the northwest. So you want to put those bolts in the water pipe facing due south. So that way the blades can sweep all of this wind, and all we're going to miss then is this little bit here where the blades cannot go that far. So I don't know if I made it clear yesterday or if I wanted to make it clear today. So that should make more sense on how to mount your pole with a rotation stop. So with that out of the way, on to the electronics. Looking at the wind turbine blades from the front, you can see that the harness comes out of the lower rear side. It's got some tie wraps on it, some heat shrink. It's weatherproof. In fact, it is an automotive connector. I get these at AutoZone. What you do is you just cut it in half, and then you have a keyed outdoor weather-ready connector. And I think they're like $2, not a big deal. So here's the other half of that, heat shrunk and spiral wrapped, and that SO cord is what goes into the shed to bring the power in from the turbine. Let's talk a little bit about wind turbine in general. We know that as the wind speed goes up, the voltage goes up, right? That seems kind of elementary. But the conventional wisdom is that as the voltage gets above, say, 15 volts, we just dump that into a resistive load, or I've seen people use like their water heater element for the excess voltage. And you know, I think that's kind of wasteful. We should be able to use that energy, and my wind turbine is only making 35 watts, so I decided that rather than just dump everything above 15 volts, that instead we would take everything above 15 volts and regulate it back down to 15 volts. Seems a lot more efficient to me, and this will work all the way out to 40 volts. 40 volts is the cutoff for the circuit we're going to build. Rather than just dumping that, that just always seems weird to me. So the circuit we're going to build is from Renewable Energy website in the UK. It's based on an LM317 3-terminal adjustable regulator. It's a pretty simple circuit. The LM317T, the adjustment terminal, is your output is determined by R1 versus R2, this voltage divider here. And that voltage goes into the adjust terminal, and that sets your output. The 317T is limited to 1.5 amps though, and so this tip 147 Darlington pair handles the bulk of the current. So this particular regulator in this form will handle 40 volt up to 40 volts at 10 amps, and it will turn it all into whatever you set it for. In our case, it's around 14 or 15 volts. I changed the circuit just a tiny bit for mine. I beefed up the capacitances a little bit, and I made R2 variable. And that way I can set my output voltage under load in the field. So here is my circuit, and you'll have to forgive me. I'm using easyeda.com CAD here, and I didn't get this terminal at ground. So use their circuit, not mine. But as you can see, I beefed up the input and output capacitances significantly, and this voltage divider is for 10 to 1. This should be a 10K and this should be a 1K. I chose a 20K pot, so that way I have a lot more sweep, a lot more variability, rather than being, you know, bottomed out on a 10K pot. And there you go. So just those couple little changes is all I made. Here are the components, and this little project box was so close to working, but it just wouldn't fit, so we didn't wind up using the project box. If this intimidates you, why don't you contact like your high school or a trade school, or put an ad on Craigslist. I'm certain that somebody who lives near you can build this circuit. It's not that bad. Here it is completed. You could say that for 35 watts it's over heat sinked, but those are what I had kicking around in the junk box. So here we are, proof of concept and testing. You can see the variac in the background that puts out a variable AC voltage. It's then rectified and sent on to the regulator circuit that we made. And as you can see, we got 40 volts in, 15 volts out, just like we planned. So I think that that's a lot better use of our time and effort than just dumping power generated by the wind turbine. So we found a 3-gang electrical box at the home store. It's the 2.5-inch deep one, and it seems to fit the circuit just fine. However, I want to make a note that when this gets built, these heat sinks and the screws are at 15 volts. They're at your output voltage. So you cannot mount this so that the heat sinks are touching your box, or any of your solder joints are touching your box. Otherwise, you're going to ground it out and you will get no voltage, which is not what we want. So while you're in the aisle picking up this box, get yourself a single gang unbreakable blank. It has to be unbreakable, because what you're going to do is you're going to mount your circuit to the plate so that you're not touching the heat sinks or anything else, and you're going to mount the plate inside the box. So that way, this whole circuit board and heat sinks and screws and joints are all isolated from ground. Otherwise, you're not going to make any power. And this was all for nothing, so don't do that. Here is the circuit finished in the box. Got a row of terminals there with the potentiometer peeking out, ready for installation. We mentioned that the regulator circuit can only handle 40 volts in, and the motor we're using is 120 volts DC at its full load. So we can't be having that. So what we've done is we put C1 is the input to the regulator. I just didn't draw it in the rest of it in CAD. We put a relay, which looks like that. It's a 32 volt AC DC, 10 amp double pole double throw from our friends at All Electronics. I shop there a lot. I love them. It's surplus. It's good deals. I think that was $5. While you're there, buy 2, you know, to have as a spare. So what we did was we hung that relay across the raw output of the turbine with a 1.8K bias resistor. And Easy EDA CAD does not have normally closed contacts in the library, so this should be normally closed. I apologize. So as the voltage approaches 40 volts, it energizes this coil, opens the contacts, protects the regulator. With the hysteresis in the coil, the voltage from the turbine has to drop down to around 10 volts for this relay to de-energize, go back to normally closed, and put voltage back into the circuitry. So overall, it seems really simple, and it is, and it works. And for $5, it seems to be the way to go to me to protect our circuit from overvoltage. Here is the solar panels on my solar shed. It's a pair of 20-watt solar panels, and the whole reason for the wind turbine was because this was not enough power for my solar shed. So now we have two sources of power in the shed, and I want to keep with just one charge controller. So what we're going to do is we're going to install a pair of blocking diodes. So we're going to take the power in from the solar and the power in from the wind through a pair of blocking diodes. These are RHR 15120s. You don't have to go quite this severe with them. These are way overkill. They're hyper fast recovery. The thing that I like about them, though, is that their forward bias is only 0.3 of a volt, whereas a normal silicon diode would be 0.6 or 0.7 volts. And with the amount of power we're making, we can't be losing anything to voltage drop. So what this does is it takes the power from the wind and from the solar and gives it to the charge controller. If you didn't have these blocking diodes and you just had the solar and the wind connected to the terminal, on a non-windy day, the solar panel would turn the wind turbine backwards. And that would be counterproductive, so let's not do that. And then, of course, the wind grounds and the solar grounds all get connected together. So here is the circuitry in question. They're on a breadboard right now. I'm waiting on a Hoffman box to get it painted to put all this junk in. But as you can see, it's all laid out there on breadboards. Here you got your voltage regulator and your inverter. Here is the wind shutoff and the wind overprotection relay. The 1.8K resistor for that overvoltage relay, all they had at All Electronics was a 5-watt. I think that's probably overkill, but it's what they had. And then here are your RHR 15120 protection die, protection diodes, close enough, to keep your wind and solar apart. And here is fusing and a 100 amp DC breaker for your battery bank. I see a lot of these on YouTube, and I don't see very many fuses or circuit breakers. Don't burn down your shed. Use a breaker. Don't be silly. Here is the charge controller we're using. It's a Sun Yoba, and these take a lot of shit on eBay because they're advertised as maximum power point tracking, MPPT, and they're not. They're PWM. We all know it, but this is a 40 amp capable charge controller, and it was $41 on eBay. It's got a nice display. It's got a battery low voltage shutdown. It's got timers in it you can program. It's a nice little unit for $41, and we know it's not MPPT. That's fine. So we have the solar and wind through the diodes connected to here. Of course, then our battery and our inverter. This thing's been in service. It hasn't even hiccuped. There's no reason to not use it. If you want to spend a couple $1,000s on a charge controller, go right ahead. See if I care. And so here's the deal. If you don't want to build that circuit, and if you're willing to take a chance, you can go on my favorite shopping place and get a John Deere voltage regulator for a tractor. Output should be 12 volts. The only problem is that I don't know what the maximum input voltage is. Should be good for at least 20 or 30 amps. It should do what we want, but I can't recommend it in good conscience because I don't know what the maximum input voltage that it'll take is. If you want to spend $13 and find out, that's up to you. But yeah, if you wanted to try this, let me know in the comments. Let me know what you think. If you know a John Deere mechanic and you have access to the manuals or something, let us know. Let the people know. That's about all I've got. If you have any questions or comments, please post them. Otherwise, have a good day.